Alright class, welcome to another lesson. Today's learning goal is I can use proportions to find the lengths of similar figures. So, a scale drawing. It can be a reduction, or that means to make something smaller, such as a map or floor plan, or an enlargement, such as a drawing of a blood cell. When we make a small blood cell and make it into a bigger picture, okay? Making it bigger, an enlargement of an actual object. The scale of the drawing is a ratio of the size of the drawing to the size of the actual object. In other words, is the size of the drawing divided by the size of the actual object. Okay. So, over here, objects that are proportional are called similar figures. Okay. That means that here, this triangle ABC, okay, right here, oops. Right here, this one right here, this figure looks exactly like this one, except it's scaled up larger. Okay, so this is the new one, and this is the old one. Okay, so this is the actual object, and this is the new drawing. Okay, so every single one of these lengths is enlarged by the same amount, or excuse me, by the same factor. Okay, so here, if triangle ABC is the original triangle, which we said it was, what is the scale of triangle ABC to triangle DEF? That is, what do I have to multiply each one of these lengths by to get the lengths of the other triangle, DE and F? Okay, and the answer to that is we find it by finding the size of the drawing over the size of the actual object. So over here, we could use 15 divided by 10. Okay, that gets us a factor, or the scale is 1.5. Okay, which, as we know, right here is 1.5. Okay, so we take the drawing length divided by its similar other length. Okay, now let's try another one. The scale of a map of Louisiana is 1 inch equals 50 miles. Okay. Find the actual distance from Zachary to Franklin if the distance on the map is 2.75 inches. Okay. So, here, 1 inch is 50 miles. Okay. So we need to find out what 2.75 inches is in terms of the ratio. Okay. So the scale length is this one right here, Okay. The actual distance it represents is this one right here. So we have 1 inch. It's very important to use units in this one because these two have different units. One is inches, the other one is miles. So we got to make sure that we're keeping those consistent. The actual distance is 50 miles. And we know that the map length is 2 inches, 2.75 inches. Okay? We don't know the actual distance. So we're going to make that x. Okay? So we have set up now a proportion. Okay? This is the first ratio right here, and this is the second ratio right here. And this also represents the scale. That is 1 inch equals 50 miles. And again, we're going to solve this in a very similar way to we did yesterday, or in the last lesson, which is we're going to use our cross products. We're going to multiply the extremes by the means. And when we multiply the extremes, we get x equals, and then we do 50 times 2.75. That is 137.5. And because miles was on the bottom in the first ratio, it's also going to be the unit for x as well. So it's going to be miles. Okay, 2.75 inches on the map represents 137.5 miles. This question, Roy made a scale drawing of the schoolyard using a scale of 2 centimeters to 3 meters. He measured the gym and found that it had a length of 60 meters. What is the length of his drawing? Okay. So we have a scale of 2 centimeters to 3 meters. And we know that the gym is actually 60 meters. Okay. So right here, we don't know what the length of his drawing is. So we use x. Then we're going to do our cross products. So 2 times 60 is 120. And 3 times x is 3x. We're going to divide both sides by 3. So we get x equals 40. Okay. So we have 40 is x, but we need to figure out what the unit is. Because x came from the top, and in the other ratio, centimeters was the unit, so our unit is going to be centimeters. So on this scale drawing, the schoolyard should be 40 centimeters. Here we have two images that are similar. That means they are scaled up from one another. So this one over here, because we have all the information on it that we need, is the original. Over here, okay, this one is the model, okay, or the new drawing. Okay. So our scale is going to be, we know that 18 meters becomes 22 meters. Okay, so 18 meters becomes 22 meters. We're trying to figure out what 81 meters becomes if we do that. Okay, so we set up our proportion like this. 18, which comes from the first part right here, becomes 22, so we're going to do 18 to 22. Here, we start with 81, and goes to x, so we're going to do 81 to x. Okay. Okay. So we've now set up the proportion. I'm going to rewrite the proportion so it's a little bit easier to see. Or erase some of this right here. Okay. Again, we're going to multiply the means together and the extremes together. So our extremes and then our means. When we do that, we find that we get 18x equals 22 times 81, which is 1,782. Okay. We're going to divide both sides by 18. We find that x equals 99 meters. So therefore, x equals 99 meters. Okay, and we got meters because our top unit is meters right here. Or excuse me, our bottom unit is meters right here, so therefore x will have a unit of meters. Here we have again two similar figures. Okay, that means that this image right here on the right, new drawing. Okay. It's just scaled up from the original, which is right here. Go ahead and try to find what x is on your own. To find what x is, we're going to set the proportion of 5 centimeters becomes 7.5 centimeters. And we're going to ask, what does 8 centimeters become? Okay. So, again, we're going to use our cross products and multiply our extremes by our means. We have 5x equals 8 times 7.5, which is 60. We're going to divide both sides by 5 to isolate the x. X equals 12, and because centimeters was our unit in the bottom right here, it's going to be our unit for x. X equals 12 centimeters. Our last question here. The figure on the left represents a scale drawing of the figure on the right. What is the scale? Okay. So over here, our scale was 5 to 8. Okay. Here it says the figure on the left represents a scale drawing of the figure on the right. What is the scale? Okay. So we have 2 inches is the same thing as 5 yards. Okay. We need to figure out what 1 inch is then. So we have the ratio of 2 inches to 5 yards. And we are asked to give the scale for 1 inch. So we know 1 inch right there. And we don't know how many yards that is. Okay. So here, again, we're going to multiply our extremes and then multiply our means. So we get 2x equals 5. And then we're going to divide by 2 to both sides to isolate the x. X equals 2.5. So therefore our answer is 1 inch. For every 1 inch, we get 2.5 yards.